Right guys, so welcome to the video for Leetcode question, and today we will be discussing some of subarray minimums. Now this problem has got many likes and it's a good problem too. So what the problem states is we are given an integer, we are given an array of integers and we want to find the contiguous subarray, and we want their what's the minimum value of the contiguous subarray. So for example, if we have a 3 1 2 4 as an array, then for every contiguous subarray, what's the minimum which we will get. So let's suppose we will start from 3. So 3 has got only one element, which is the minimum element. So 3 1 2 4 are single elements, and then if we start for looking contiguous subarray, so what's a contiguous subarray if you are asking, then the contiguous subarray means there should not be any gap in between searching. Like we cannot go from 0 1 4 5. We cannot use those subarrays. We will need to use 2 3 4 5 6. That means the continuous element subarrays we need to use. Now let's start here. So the subarray is 3 1. So what's the minimum element for 3 1? It's 1. For 1 2 is 1, and 2 4 2, and similarly all the other elements, all the other subarray will include their minimum elements. So after calculating all the minimum elements, so let's say 3 for 3, then 1 for 1, 2 for 2, 4 for 4, and for 3 1 minimum element is 1. So similarly for all the subarrays, we got the minimum element. Then we want to sum those up, and sum is 17. Now as we can see that there is a brute force approach, that we may calculate all the subarrays, and then we may find the minimum element of all the subarrays. But if you find this, if you code for the brute force approach, then it will be 2 raised to n means time complexity, which is pretty large, and interviewer does not expect to go for that kind of approach. And as the sum could be large, so because it includes all the subarrays, so we need to return the modulo, which is 10⁻². Now how are we going to approach to this particular problem is, let's suppose this. Okay, so first question arises that how we will calculate these subarrays. Okay, so let's suppose we come to an element which is 3. Now first question is, how many subarrays are there which will include 3 as their minimum element. Now if we see what is the left side of 3 which will include, means how many subarrays are there in the left side which will include 3. So there are till 8 3 includes 3, 7 8 3 also includes 3, 9 7 8 3 also includes 3, but 2 9 7 8 3 does not include 3, because now here 2 is the minimum element. So it will 3 will not be considered in 2 9 7 8 3. Now how many subarrays are there, which contiguous subarrays are there which will include 3 on the right hand side. So it is 3 4, 3 4 6, and it does not include 3 4 1, because now 1 is the minimum element in this. Now we need contiguous subarray, so we can't have just 3 4, we can also have 8 3 4 also. So how are we going to find all these subarrays? Now here the intuitive approach is that we need to what choices we have. So let's suppose we have 4 choices to make. We can make 8 2 3, then 8 2 3 to 4, and 8 3 4 6. So we have 8 2 3, we can have 8 2 3 to 4, and we can also have 8 2 3 to 4 to 6. So we have if we calculate all those choices, so left subarray will have total number of 4 choices, and the right subarray will have in total 3 choices. So how many subarrays will it include in total? So it will be 4 into 3, which is 12 subarrays. So we need to find this number, which will include 12. Now there might be multiple elements too, so we will take care of that in while we code. And okay, so this is the approach. Okay, so let's say how are we going to solve these problems? So let's say we store an index for the previous less element. So let's suppose we start from 2, and now for starting for 2, what is your previous less element for 2, which is none. So we will store I plus 1, that is 1. Now is there any less element for 9? Yeah, there is. So we'll store again 1 element. Now it is at a distance of 1, so that's why we have stored the distance. Now any less element for 7? For 7 the distance is at 2, that is 7 to 9 and 9 to 2, so we'll store it as 2. Now we can fill all those things, but how are we going to fill those things? Okay, so in that situation what we are going to do is we are going to maintain a stack. Okay, and this approach is called monotonic stack because let's see, so we will start from the first value. Stack is empty, we will store the index, we will store the index site. Okay, so we store the index. Now after that is we want to find the previous less element. So is 9 is greater than 2, so we'll still be storing 1. Now is 7 7 is less than 9, so that means we need to find a less element for 7. So we need to pop this out, and what we need to do is we need again to check, is there any element less than 7? Yes, there is. So what we will do is we will go and we will check the distance for that. So this is at index 2 and this is at index 0, so total distance is 2 minus 0, 2, so we'll store 2. So in this way we are going to store the distance for the previous less elements. Now when it comes to next less elements, so we have suppose next less elements to calculate. So how are we going to calculate the next less element? Now if you might be asking why we are calculating previous less element and next less element. It is because we want to check how many subarrays are there which will have the particular element. So for example we have 3 here. Now how many subarrays are there which will have 3 in the left side and on the right side? So in total we have at this much, so till this much we will have 3. Now previous less element we got 2, so it will not contain 3 as a previous less element. So that is why we are calculating previous less and next less element. Now for next less element we will again maintain a stack, and what we will do is we will start by putting 2 index, again index, now index. Now next less element is 9, the next greater element for 2, yeah it is. So what we will do is we will store the index, which is 1 minus 0, 1. Next what we is yeah, so 7, just 7. Now what we need to calculate is which is the next element for greater for 9. So is 7 the greater for 9? No, it's not. Is 8 greater for 9? Next we want, we want next less element. So is 7 less for 9? Yeah it is. So what's the distance for it? It's 1. And also here we will store still 1 because we didn't got the next less element. 9 is greater than 2. Okay, so that was my mistake for them. Okay, then we will start again traversing for 7. Is 8 less than 7? No, it's not, so we'll store it here. Is 3 less than 8? Yeah it is, so we'll store we will check the distance from 3 to 8. It is 1, so we'll store 1. Then is 3 less element for 7? Yeah, it is. So what's the distance? It is 2. Then is, yeah, we calculated for 9, so this will not be in position. So in this way we are going to form these sum of subarray minimums, and let's start coding for this. Okay, so what's the first thing we need? We need a vector. Let's say we need PLE, that is previous less element, next less element, and it will have a size of n. Size of n, what's n? Its n is dot size. And next what we need a stack. Now why we need a stack is because we need to find the previous less element and next less element, so that we will pop those out whenever we will meet our condition. So we need a stack ps and st. Let's say okay. Now we will start traversing the array from 0 to a dot size. Then what we are going to do is we need to find first previous less element. Okay, so how are we going to do that? Okay, so we need to first check if the stack is empty. Now at first stack is always empty, so we will say if ps.empty holds true, means it should not be empty, and ps.top should be, that means ps.top, yeah, so previous less element. Previous less element means 9, so for 9 is greater than 2. That means I got previous less element right away. So my if ps.top is greater than, if it's greater than a of I, then what we are going to do is we are going to say ps.pop, and then last we will do is a of, okay, so we need to store the previous less element, so which will be pli, which will be if it is empty. If it is empty, then we will store -1, so I plus 1, because there might be a condition where let's say this is the graph, so there might be condition that there is no previous less element. So the ones which will if there is no previous less element, that means it will have value of I plus 1. Okay, so now it has an I plus 1, and if it is empty, if my stack is empty, and if the stack is not empty, then I will store the distance, that is I minus ps.top. Now the main thing is here base conditions. Then write the base conditions. Okay, so we will start from 0 and we will go for a dot size, and what we will do is we will store all the i's to be equals to I plus 1. That means we want first our base condition that we have the means we have no minimum less element until now, and similarly no next less element. So we will store in now we got our previous less element. Now we need to go for next less element. Okay, so what we will do is we will say ps if ns.empty does not hold true. What we want to do is we want to check if there is an element which is at top which is greater than a of I. So if it is, if that element is there, we are going to use push. Now for next element, yeah, so what we need to do is we need to first check if my top is if my a of so if my a of ns dot top is it greater than a of I. So if it is greater than a of I, then I need to that means that is my next less element. So let me show you. Okay, so if we go for next less element for 9, so 9 is greater than 7, so my next element is at a distance of 1, that means 2 minus 1. Okay. So what we will do is int x is equals to ns dot top, we will say ns dot top because now we got the next less element for 9, and we will store that at nl next less element I is equals to I minus x. Okay, and at last we will push the current I. So I guess this should be the code. This should work. Okay, so we have calculated PLE, we have calculated NL, and okay, now what we want is a variable to store the answer and a mod to be equals to this much, and what we next want is we will start from 0. Now as we got our previous less elements and the next less elements, we the formula states like this. Okay, so the formula is a of I, that means this much, this so yeah, so this is our formula. So why this formula holds true? Because we want previous less elements and next less elements, that means 3 will come in 3 will come here too and here too, that means previous into next, and how many 3's are there, we will multiply that. So n plus and answer is equals to answer plus, now means we want mod 2, right, because answer could be very big. So it's mod, so answer is PLE of I into NLE of I into A of I. That means we got this many minimums. Now we will just open this. So if there is no syntax error or anything, it should work. Alright, so it's working, and as you can see, okay, let's try to submit it. There is no check. Sure, yeah, okay. So this was the code for some of Subarray minimums, and even if you didn't find my approach helpful, then I will try my best to give you the solution in a text format. So join my Telegram channel, it's in the description box. So like, share and subscribe this. Cheers.